One of our usual techniques in calculus is going to be to use what we know how to solve problems that we don't by extending what we have. So we know how to handle this guy here. It's the integral of u to the 9th with respect to u. So we add 1 to the power, making u to the 10th. We divide by the new power, and since this is an indefinite integral, we add in a plus c. Okay, we want to use that rule that we have to try to solve some problems that almost fit that form, but not quite. For example, suppose that we had the integral of x plus 7 to the 9th dx with respect to x. Well, it's very similar in form to what's up here, but instead of having a single variable on the inside, something we have a rule for, we have an expression on the inside. But if I look at that, if I would make a little substitution, if I would just replace u with x plus 7, I know that the derivative of u with respect to x is simply 1, or solving this, I know that du and dx are exactly the same thing. So what I can do is I can rewrite my original integral in the form x plus 7 is replaced with u. It would be to the 9th power. And dx and du are the same thing. So I'm back to where I started. And this is going to be u to the 10th over 10 plus a constant. But the original problem had nothing to do with the variable u. So we need to switch it back to where it started, and we'll just put back in that u is x plus 7. So our answer is this is x plus 7 to the 10th over 10 plus a constant. Now, the author calls this process pattern recognition because we see the pattern, and that's fine. I like to make it a little more structured because this structure will not only work on the easy ones like this, but it will work on the ones that are a little more difficult as well. And our next example, we'll look at one of those that is slightly more difficult.